Hello and welcome to the sixth experiment of Cisco Packet Tracer Lab. In this experiment, we are going to study access control lists. Access control lists are basically security features which can restrict what information can be accessed by whom. So, in this particular configuration, we have a network 10.1.2.0 which is consisting of two PCs and a multi-layer switch connected to a router. Similarly, our network 10.1.1.0 which is connected to the same router. Both of these networks are in turn connected to the internet. So in this experiment, our aim is to make sure that we configure access control lists based on the instructions given. So let's look at the instructions given first. The first instruction is that we need to use access list number 100. Then we need to ensure that the PC1 can only access the HTTP server 1 using HTTP protocol on subnet 10.1.0, which is nothing but the PC1 in this network should only be able to access the HTTP server 1 using the HTTP protocol. Similarly, we have the next instruction. Inside PC2 can only access the HTTP server 2 using the HTTPS protocol on subnet 10.1.0. This means is that the PC2 in this subnetwork can only access server 2 using HTTPS protocol. No other PCs or servers on subnet 10.1.2.0 can access subnet 10.1.1. What this means is that no other PC or network device which is connected to this network 10.1.2 should be able to access any device in the subnetwork 10.1.1.0. The next instruction given is that hosts on subnet 10.1.2.0 can access any other network, which means that other devices in this particular subnetwork or including in PC1 and PC2 should be able to access anything other than these two servers. Any other network, basically even this one. The last is the bind access list in the most efficient place on router 1. Okay, so now that we've understood the instructions, let's try to configure this on the router. So we'll be restricting this and and configuring the ACLs on this router 1. So as you can see, the first command I use is enable to enter the privilege mode, and the next command I use is configure terminal to enter the config mode. Then I use the command access list, which gives me two options: standard access list and extended access list. So what is the difference between the two? Standard access list allows you to put up access list based on the and restrict packets based on the source and the destination of the packet, whereas extended access list allows you to restrict packets based on the source, destination, and the packet type. So since here we are restricting the packets using their type, which is HTTP or HTTPS, we are going to use access extended access, and we've been told to use the access list number 100. So that's why we are going to use the access list number 100. So the first command that we use is access list 100 permit TCP. Basically, it will allow you to allow TCP traffic. The next command is this is an incomplete command. The command is access list 100 permit TCP host 10.1.2.101 space host 10.1.1.100 EQ80. So what does this command mean? This command means that any host from 10.1.2.101, so the host this, which is nothing but the IP address of the PC, can be send TCP packets to the host 10.1.1.100, which is the server, using the port 80. So you might know that this port is equivalent to the port for HTTP. So this basically command suggests that the PC can access the HTTP server using TCP, but only on the HTTP protocol. Similar, so this is how we configured this particular instruction, that the PC1 can only access server 1 using HTTP protocol. Similarly, for the next instruction, we use access list 100 permit TCP host 10.1.2.102, which is nothing but the IP address for PC2, and host 10.1.1.10, which is nothing but the IP address of the server 2, EQ443. As you might know, 443 is the port number for HTTPS. So this is how we configure the next instruction, and uh, which is that PC2 can only access HTTP server 2 on the HTTPS protocol. The next command is access list 100. Sorry. Yeah. So the next command is access list 100 deny IP 10.1.2.0 space 0.0.0.255 space 10.1.1.0 space 0.0.0.255. So what does this mean? So this means that any uh, host on the network 10.1.2.0, which is nothing but the network here, any host is given by using this particular uh, 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 key. 0.0.0.255 signifies all of the hosts. This basically means that none of the hosts in this network will be able to access any of the hosts in 10.1.1.0, which is this network. So using this command, we can configure this instruction uh, that no other PCs or servers on subnet 10.1.2.0 can access subnet 10.1.1.0. Similarly, we can also configure the next command, which is hosts on subnet 10.1.2.0 can access any other network. So here we use access list 100 permit IP 10.1.2.0 space 0.0.0.255. That means any hosts in the network subnet in the network 10.1.2.0 space any, which is it can be permitted to access any other network. So now that we've configured everything, the next thing is to bind this access list to the router at the particular interface which is the most efficient. So there are so this is a particularly interesting thing or on deciding where to uh, deploy the access list, bind the access list. So in this case, the most efficient place is the interface 0/0/0 or the interface between the PCs. This is because we don't want, this is the closest place for the router, and this will not make the router do a lot of processing and drop packets. So that is why we use this particular interface to bind the access list. So the next commands that we use will be used to bind the access list. So as you can see, we again go to configure mode. We use the command IP access list extended 100, uh, and then we use the command int to go into the uh, access list. So basically, this is used to access the access list, and then we use the command int g0/0/0. What this does is it basically will help you to bind it to this interface, and we use the command IP access group 100 inbound, which means that we are giving this particular interface the access list as an inbound traffic. So this is that's it. We are done with the router configuration. So now let's check whether our configuration works, and is the access control list actually working, and can we restrict our traffic. So let's check whether PC1 can access the server 1 using HTTP. So what I'll do is I'll go to the web browser and try to access server 1. So I'll try to write the IP address of server 1. As you can see, yes, this is able to access the server 1. But now we need to restrict it access from server 2. So basically PC1 should not be able to access server 2 because we've configured it as such that PC1 can only access server 1 using the HTTP protocol. So let's check whether this works. It shouldn't. Uh, so as you can see, there is no update in the page, and pretty soon we will see the request will be timed out. So as you can see, because there is no reply from the server, it will drop the packet and the PC will not get a reply back. So that is why we get the request timed out. Similarly, we need to check whether PC can ping the servers or not. Ideally, it should not because we've only allowed HTTP traffic and ping does not use HTTP protocol. So let's check whether this works. I'll try to ping the server 1 first. So as you can see, destination host unreachable. Similarly, even the other server will not, ideally should not work. Yeah, so the destination host is unreachable. So as you can see, our access control lists have been configured properly and have been binded to the router, and thus we are restricting the traffic according to the instructions we've been given using access control lists on router. Thank you.